Hi everyone. I'm excited to share my project for this week. I'm going to give the general overview and then I might focus in on a few of the components because right now it is probably hard to see exactly what's going on. I've got like a rat nest of wires here, which makes it really hard to decipher what in the world is happening. So I'll try my best to explain it. Obviously, the blog will have schematics that will make it even clearer, but we'll start with general review. I'll focus on some of the elements of my project, and then in a separate video, I'll demonstrate its operation. All right, so here's the big overview. I built a fan, and more specifically, I built quote unquote a smart fan that adjusts its operation based on environmental conditions. So I have two sensors that I incorporated into my project. There's a photoresistor in here and also a temperature sensor. And I basically am using the sensor readings to adjust how fast the fan is spinning. So if there's more light, for example, shining on the photoresistor, in my sketch, I have things set up so that the fan spins faster. If the temperature is higher, then the fan will spin faster. And I figured in a real world application, this could be useful in a fan. If you place a fan in a window, for example, you may want that fan to spin faster if sunlight is beaming through the windows. Or you might want the fan to spin faster if it's just hotter. So this is sort of the idea behind my design. Furthermore, I have a manual piece to my project that's associated with the potentiometer I have here. And the potentiometer adjusts a parameter. More specifically, it adjusts the minimum temperature at which the fan will operate. So by turning the knob, I can change the temperature that will decide whether the fan will spin or not. So if I set, for example, my potentiometer to 75 degrees, the fan will spin at any temperature above 75 degrees, but will not spin if it's below 75 degrees. I figured that kind of adjustment in the real world would be especially useful if you only want your fan on for certain temperatures. You'll also see in this build, sort of pretty obvious, I guess, it's gigantic. I've got some D-cell batteries over here. I found over the course of my project that I was far more successful in having accurate sensor readings if the motor that's running the fan is operating on a separate power source than the sensors. So I had the sensors operating via the 5-volt power from the Arduino, and then the motor is operating via these three D-cell batteries, and they are about 1.5 volts apiece. So you have close to about 5 volts of power here, or voltage here. And so the fan is operating via this, and then everything else on the board is operating with the 5-volt power from the Arduino. All right, so let's go ahead and focus in on some of the specifics here. I'm going to try to zoom in to make it a little bit clearer. Here we go. So I'm zooming into the Arduino board here, and I'm going to zoom into the top. Again, could be really hard to see, and I apologize, but I will have circuit schematics in my blog that will make this a little bit clearer. In the upper portion, the upper left hand quadrant, I have some elements here that are essential for the running of my motor, which is my fan. I have a diode here, and I have a transistor up here. Now, the transistor operates in conjunction with the output pin of the Arduino to essentially turn the motor on and off, and more specifically, to change the amount of current that's running through the motor, thus changing how quickly it is spinning. And that transistor is kind of a key piece because the Arduino itself cannot directly power the motor via the output pin. So we need to have the output pin affect the motor's operation, but we need also another power source to keep the motor spinning. And in this particular case, I'm using the D batteries. But you could have used the 5 volts from the Arduino, and that would have also worked. I have this diode here, and the diode, I learned, is important because you get something called flyback voltage that occurs whenever the motor stops operation. And this is tied actually to some physics, which as a physics teacher I'm quite excited to talk about. It's tied to the idea that if a motor stops spinning, there's going to be induction of current to essentially try to keep a form of equilibrium within the spinning motor. So there's a magnetic field that sets up, we call that induction, and the magnetic field is trying to essentially bolster the magnetic field that's going away due to the fact that there's no longer a current being sent to the motor. And that creates another voltage, another potential, due to the fact that you're getting this induced current. And that voltage, apparently, I didn't know this before, could be detrimental to the transistor, can cause issues. And so one way to essentially dispel this extra voltage is to use a diode here, which allows the current to harmlessly run through as that induced current kind of eventually dies out. All right, so that's the motor portion. And then we have down here, I'll kind of shift things a little bit here. Down here we have our potentiometer, which is connected to one of the analog inputs of the Arduino. And you know, we've used the potentiometer quite a few times now, and or at least I have, I guess. And it operates with 5 volt and ground, and the middle pin, which is again sort of like a voltage divider here. In the middle pin we have the input. All right, so there's that. Next, you'll see in the upper right hand corner here we have LED. This is the RGB LED, and it's set to be either blue or red. It will shine blue when the motor is off, which means that the manual setting from the potentiometer has set a minimum temperature, and currently the temperature sensor is reading a temperature that is below the minimum temperature at which the fan will operate. So it will be blue when the motor is off. And then when it turns on, this will turn red, which you'll see in my next video that shows the operation of the circuit. All right, and then finally, let me zoom in as best I can to the final section here. So in this final section, we have our sensors, which is a little hard to see with all these wires, but we've got the photoresistor and the temperature sensor. The photoresistor requires another resistor, so I've got the 10,000 ohm resistor here, and it functions like a voltage divider as well. If there's more light shining on it, then you have a situation where there's more voltage across the photoresistor, which can be picked up by the analog input of the Arduino. And then the temperature sensor is a thermal resistor essentially, and also is connected to one of the analog inputs, but obviously a different pin than the photoresistor. All right, so there is an overview of my circuit. There's a lot in there, but in the next video we'll give you a quick rundown of its operation.